Theoretical yield is the maximum amount of product that can be obtained in a chemical reaction, and we calculate this from the limiting reagent. So the theoretical yield is something that's almost never obtained. You would only obtain the theoretical yield under perfect conditions where no product was lost in the process. The actual yield is the amount of product that is actually obtained from a chemical reaction. And so the actual yield is the amount of product you would actually obtain if you did this experiment in a lab. And these values must always be experimentally determined. So if you're doing a problem involving theoretical and actual yields, the actual yield would always have to be given to you. It's not something you could calculate looking at the balanced equation, where the theoretical yield can be calculated using a balanced equation. And your actual yield can never be more than the theoretical yield, which just means that you can't ever obtain more product in an experiment than is theoretically predicted using the balanced equation. The percent yield then is a ratio of the actual yield to the theoretical yield, and you multiply that by 100 to give you a percent. Let's go ahead and look at an example. If 16 grams of CaCO3 are decomposed and 7.54 grams of CaO are obtained, what is the percent yield of CaO obtained? Well, you'll remember from looking at our last slide that the percent yield is always a ratio of the actual yield over the theoretical yield. So in this problem, 16 grams of calcium carbonate is the amount of reactant that we're starting with, and 7.54 grams of calcium oxide is our actual yield. So the first step is that you always need to check to make sure your equation is balanced. Sometimes you'll be given balanced equations right from the beginning, and sometimes the designer of the problem will expect you to balance the equation on your own. If we look at this reaction, we'll see that our equation is already balanced. 1 calcium atom on each side, 3 oxygen atoms, and 1 carbon atom on both the reactants and the product side. For the second step, we need to calculate the theoretical yield of calcium oxide. So like I mentioned previously, 7.54 grams of calcium oxide is our actual yield, and now we'll calculate how much could theoretically be obtained if the reaction was conducted perfectly. Now remember, we can use the coefficients in our balanced chemical equation to convert from one reactant or product to another reactant or product. But remember, if you're going to do that, you can only convert between reactants and products if you're in moles. You can't convert directly if your reactants and products are in grams. So we'll start this calculation with the amount of starting reactant given in the problem. The problem says that we started with 16 grams of calcium carbonate. Now to convert between calcium carbonate and calcium oxide, we need to first convert calcium carbonate to moles. And we'll do that using the formula weight, which is 100.1 grams of calcium carbonate per mole of calcium carbonate. And we put grams on the bottom because those are the units that we want to cancel out. Now that we have moles of calcium carbonate, we can convert to moles of calcium oxide using the coefficients in our balanced chemical equation. And this is why it's very important to check that your equation is balanced. In this case, 1 mole of calcium carbonate will give us 1 mole of calcium oxide. This allows us to cancel out moles of calcium carbonate and leaves us in moles of calcium oxide. But we want to calculate our percent yield, and because our actual yield is in grams, we need to calculate our theoretical yield in grams. So next, we'll convert from moles of calcium oxide to grams of calcium oxide using the formula weight of calcium oxide, which is 56.1 grams of calcium oxide per mole. This allows us to cancel out moles of calcium oxide and gives us a theoretical yield of 8.97 grams of calcium oxide. We now have our theoretical yield, and we can calculate our percent yield by taking our actual yield given to us in the problem. Remember, the actual yield is something you can never calculate on your own. It must be given to you, divided by our theoretical yield. And when we multiply this value by 100 to get a percent, we'll see that our percent yield is 84.1%. So what you may have noticed is that theoretical yield problems aren't that much different from problems you've probably already been working converting from grams of one reactant or product to grams of a different reactant or product. Except this time we're just taking it one step further and calculating our theoretical yield, which is what you've been calculating all along, and comparing that to a supposed actual yield that was obtained in a lab to give us a percent.